In the first part of the introduction to the fifth book of Euclid, we introduced ratios, comparisons of magnitude, denoted by a:b. This video will illustrate a set of definitions defining different types of ratios. One special case of ratios is when A is to B as B is to C. The simplest but still interesting case. It is said that A is to C is the duplicate ratio of A is to B. This is because, it turns out, A is to C as A squared is to B squared. If A is to B as B is to C as C is to D, then A is to D is the triplicate ratio of A is to B, because it turns out that A is to D as A cubed is to B cubed. Essentially, if A1 is to A2, as A2 is to A3, as so forth, as an-1 is to n, it turns out that A1 is to an as A1 to the n is to A2 to the n. Given two ratios, A to B and C to D, we will say that A corresponds to C, these are the antecedents, and B corresponds to D. These are the consequents. Given that A is to B as C is to D, the alternate ratio is A is to C and B is to D. Given the ratio A to B, the inverse ratio is B to A. The composition of a ratio A to B is A plus B to B. The separation of a ratio A to B is A minus B to B. The conversion of a ratio A to B is A to A minus B. Given two sets of magnitudes, A1 through AN and B1 through BN, such that A1 is to A2 as B1 is to B2, and A2 is to A3 as B2 is to B3, and so on, the ex equali, meaning something like from equals, ratio is A1 to AN, or B1 to BN. Given two sets of three magnitudes, A1 through A3 and B1 through B3, such that A1 is to A2 as B1 is to B2, but A2 is to A3 as B3 is to B1, we call this a perturbed proportion. These are all of the definitions we'll use in this book, and the rest of the book is dedicated to exploring these definitions.